Today I'm presenting fundamentals of cloud computing and related security issues. One topic I'll be considering under the main topic is cloud computing service model. We have three major types of cloud computing service model. One of them is infrastructure as a service. The second one is platform as a service. The third one is software as a service. What is infrastructure as a service? This is a cloud computing model where a provider delivers and manages the core infrastructure components such as service, networking, visualization, and storage over the internet. Users access these resources through a dashboard or API and essentially rent the infrastructure instead of owning it, while the cloud provider handles the physical hardware, storage, networking, and maintenance. In, Maintenance includes repairs and outages. The user is responsible for managing the operating system, applications, middleware, and data. This setup is commonly used by cloud storage providers and offers a flexible, scalable solution for businesses without the overhead of maintaining physical infrastructure. We also have platform as a service and software as a service. And one other major service that I will also be considering and talk about is desktop as a service. What is desktop as a service? This is a cloud based solution where a third party provider hosts and manages the visual desktop infrastructure, VDI, for organizations. Instead of running desktop environment on physical machines, DAAS allows users to access visual desktop that are hosted on remote cloud service. In this model, desktop operating systems operate within visual machines on cloud infrastructure, and all necessary components such as compute, storage, and networking are handled by the provider. Users connect to their visual desktop via client software or a web browser over the internet. Desktop as a service offers similar benefit to traditional VDI, such as centralized management and improved security, but shift the responsibility of maintenance, scalability, and updates to the cloud provider. It is especially useful for businesses seeking flexible, scalable, and cost effective desktop environment for remote or hybrid workforces. So, comparing and, con- and I will compare and contrast cloud deployment control element. The first one is local resource requirement. What is local resource requirement? These are the on-site computing access, such as network devices, user endpoints, such as desktops and laptops, internet bandwidth, servers, or hybrid integration component that enable or support access to cloud services. Under local resource requirement, I'll be comparing and contrasting hardware dependency between cloud computing and on-premise, which is local service. So for cloud, this this is minimal, which is the hardware dependency is minimal because resources such as compute and storage are provided by the cloud provider. For my on premises, this is high. Cost of uh, hardware dependency is high because organization must purchase and maintain physical servers, storage, and networking equipment. Which is local control, which is another comparison under cloud deployment. Control. This is the degree of control and oversight an organization retains over its infrastructure, data, applications, and security policies within its own environment, even when utilizing cloud services. And I have control over data as one of my comparison, also dependency on provider. Another comparison is my network requirement, and the last one is security. Virtualization platforms. What is virtualization platform? A virtualization platform is a system designed to manage virtual machines, allowing IT teams to create and operate isolated computing environments that utilize a shared pool of physical hardware resources. Organizations deploy virtual machines for various purposes, such as streamlining the management of diverse computing environments, maintaining legacy operating systems and applications, or running testing and application and development setups. A visual platform integrates the essential tools and technologies needed to efficiently manage and support multiple visual machines at scale. At scale. What is service-oriented architecture? Service-oriented architecture is a software development approach that builds business applications using modular components known as services. Each service represents a specific business function and is designed to operate independently, using while being capable of communicating with other services, regardless of platform or programming language. SOA promotes reusability and flexibility. Developers can use existing services across multiple systems or integrate several services to handle more complex operations. Cloud develop cloud deployment models. Here um, I have listed and treated four types. The first one is private, the second one is public, the third one is community, and the fourth one is hybrid. What is a public cloud? The public cloud allows widespread access to systems and services over the internet, making it available to individuals and and organizations alike. Since it is open to all users, it may present more security challenges compared to private alternatives. In this model, the cloud infrastructure is owned and managed by the service provider, not the end user. Public cloud solutions are ideal for delivering scalable services to many customers, even though pay-as-you-go subscription based or free models. Common use cases include storage, backup, and data retrieval. A well-known example or a well-known type of public cloud is the Google App Engine. We also have the private cloud, the hybrid cloud, and the community cloud. Issues under security, storage, legal in cloud computing. One major issue I would like to discuss in this presentation is the data loss issues. Data loss or theft is a significant security challenge faced by cloud providers. If a cloud vendor has a history of losing or compromising sensitive data, over 60% of potential users may choose not to use that provider's services. Even major companies like Dropbox, Microsoft, and Amazon experience occasional outages, which can erode trust during critical moments. Additionally, if an attacker breaches just one storage unit, they may gain access to multiple units, increasing the risk and impact of data loss.